Good day, my dear students. Welcome back to our Google Classroom. Last meeting, we discussed about continuity test. We were able to determine one function that is discontinuous at x is equal to 0. The function was f of x is equal to the absolute value of x over x. And that function is discontinuous at x is equal to 0. As a continuation, we have the second example. Example 2. Suppose our function, so is the function f of x is equal to x plus 1 if x is less than 2, x squared if x is equal to 2x minus 1 if x is greater than 2. Greater than 2. Okay? Continuous at x is equal to 2. Okay? Is this function continuous at x is equal to 2? Now, we can now use the continuity test. Continuity test, using continuity test, we are going to satisfy the first condition. F of 2 exists. Does f of 2 exist? So where's f of 2? When you say f of 2, the value of your f at x is equal to 2. So since this is a piecewise defined function, so all we have to do is to consider the specified domain. So in the first domain of the first expression in the piecewise defined function, x is less than 2. So we will not choose that expression. In the second specified domain, x is equal to 2. So in other words, if x is equal to 2, the function is x squared. So all we have to do is to substitute the value of 2 here in x squared. So 2 squared is equal to 4. So our first condition, f of 2 is equal to 4. The second condition, limit of f of x as x approaches to 2. And since this is a piecewise defined function, so we have to consider the left-hand limit and the right-hand limit. So we start from the left-hand limit. The limit of f of x as x approaches to 2 from the left, we have to consider this because x is less than 2, meaning to say we're considering all the values from the left to 2. So we have limit of x plus 1 as x approaches 2 from the left. So since this is linear, we can directly substitute the value of 2 in the variable x. So this is 2 plus 1 is equal to 3. So our left-hand limit is equal to 3. How about the right-hand limit? The right-hand limit, limit of f of x, as x approaches to 2 from the right. So you consider the domain. So we are going to consider this third expression since the specified domain is x greater than 2. So we have to use this 2x minus 1. That is limit of 2x minus 1 as x approaches to 2 from the right. And again, this is linear, so we can directly substitute 2 to the variable x. So you have 2 times 2 minus 1 is equal to 4 minus 1 is equal to 3. Now, if we're going to look at the left hand and the right hand limit, we can say that they are equal. So since limit of f of x as x approaches to 2 from the left is equal to 3, which is also equal to the limit of f of x as x approaches to 2 from the right. Therefore, limit of f of x as x approaches to 2 is equal to 3 and it exists. Okay? It exists. So the limit exists and it is equal to 3. the third condition. So, what's the third condition? The first condition and the second condition must be equal. Now, since f of 2 is equal to 4 and limit of f of x as x approaches to 2 is equal to 3, and note that f of 2 is not equal to the limit of f of x as x approaches to 2, because this is 4 not equal to 3. Okay, so the third condition is not satisfied because the third condition, first and the second condition must be equal. Okay, so since the third condition is not satisfied, therefore f of x is discontinuous at x is equal to 2. Okay? Since the third condition is not satisfied, therefore, the function f, the given function, is discontinuous at x is equal to 2. Now, there's another question. The problem is, if we can now determine the discontinuity, if we can now determine that the function is discontinuous or not, we can now move on to the types of discontinuity. Because there are 4 types of discontinuity. 4 types of discontinuity. So what are those? First, okay, since we were able to determine already that discontinuity or the function is discontinuous, then this time we will be able to determine what type of discontinuity. Now take note that there are 4 types of discontinuity. 4 types of discontinuity. Okay? There are 4 types of discontinuity. First is jump discontinuity. Jump discontinuity. Okay? Now, when can we say that that type of discontinuity is a jump discontinuity? This jump discontinuity occurs when when the curve breaks at a particular point and starts somewhere else. Okay? So first type of discontinuity is jump discontinuity. It occurs when the curve or the function breaks at a particular point and starts somewhere else. Now, what's another clue to determine if that discontinuity is a jump discontinuity? There is this. Another clue is the left-hand limit and the right-hand limit are not equal. The right-hand limit does not equal to the left-hand limit. So right-hand limit does not equal to the left-hand limit. Okay? Jump discontinuity siya if the right-hand limit does not equal to the left-hand limit. And the illustration for this jump discontinuity looks like this. There is a jump discontinuity, this one. Okay? As you can see here, it occurs when the curve breaks at a particular point. So, for example, if this point here is x, the curve breaks at a particular point, x, for example, is equal to 2. and the right-hand limit is not equal to the left-hand limit, because the right-hand limit, for example, it approaches to 1, and the left-hand limit, for example, it approaches to 0. So the left-hand and the right-hand limit are not equal. The next one is point discontinuity. Point discontinuity. Okay, when can we say that the function, the discontinuous function, is a point discontinuity? It occurs when? It occurs when the curve has a hole. When the curve is a hole, because the function has a value that is off the curve at that point. Okay, that is point discontinuity. Occurs when the curve is a whole, because the function is a value that is off the curve at that point. The next one is the third one. Third type of discontinuity, the essential discontinuity. So when can we say that a function is, the discontinuity is essential? Is essential if what? The third, essential discontinuity. Essential discontinuity occurs when there is a vertical asymptote. Occurs when the curve has a vertical asymptote. Has a vertical asymptote. Okay. If the function, that's one clue. If the function has a vertical asymptote, then we can say that it is discontinuous at that point. That can make the function undefined, and that type of discontinuity is essential. Okay. The limit, another clue here, the limit of f of x of the function f does not exist because does not exist due to the what? To the asymptote. Okay, if you're going to graph, the graph of the function looks like this. It is a vertical asymptote. So what's the vertical asymptote here? The vertical asymptote here is the y-axis. So since it is a vertical asymptote, then at x is equal to 0, the function will be undefined. And x is equal to 0 is a vertical asymptote, then it is discontinuous at x is equal to 0, and the type of discontinuity is essential discontinuity or infinite. Sometimes we can say that it is an infinite discontinuity because the limit of the function at x approaches to 0 is infinity. In this case, it is positive infinity. Number 4, we have removable discontinuity. Removable discontinuity. Okay, when can we say that the discontinuous function is removable or not? By the way, class, the first three types of discontinuity, those are non-removable discontinuity. Then the last one, we have the removable discontinuity. Then when can we say that the discontinuity is removable or not removable or non-removable? Removable occurs when you have a rational, occurs when you have a rational expression, with common factors in the denominator and numerator. Okay? Occurs when you have a rational expression with common factors in the denominator and numerator. Because the common factors will be cancelled. Okay? Since the common factors will be cancelled, then the discontinuity is removable. So, the graph for a removable discontinuity looks like this. There is a hole here. Okay? Now, by the way, class, the point discontinuity, we did not, I think, we forgot to illustrate the graph of a point discontinuity. The point discontinuity review, point discontinuity, the graph looks like this. Then there is a hollow here. Okay, that's a point discontinuity. Now, what's the clue? In this case, if f of a is not equal to the limit of f of x as x approaches a, so there is a possibility that there is a point discontinuity. Bakit? Because what? If this is our f of a and this is the limit. Now you have to take note, the limit of this exists and this is equal to at this point. But f of a is not equal to 0. So if the discontinuity happens like this, then there is a point discontinuity. Well, this the removable discontinuity, we can remove the discontinuity because the limit exists, and that limit, okay, that limit can be used to what? To redefine the function. Okay? So if we can redefine the function because using the limit, then the type of discontinuity is removable discontinuity. So for example of a removable discontinuity, okay, examples. Determine if the function is continuous or discontinuous. If it is discontinuous, determine also the type of discontinuity. So if the given function is f of x is equal to x plus 3, if x is less than or equal to 2, x squared, if x is greater than 2. Okay? Is the function discontinuous or not? We have to use the 3 conditions. We have to satisfy the 3 conditions, or we are going to use the continuity test. First, we have to identify or determine f of 2. What is f of 2? F of 2 here, because the domain is x less than or equal to 2, meaning x must also be equal to 2. So, if x is equal to 2, we are going to use this expression. 2 plus 3 is equal to 5. How about the limit? Since this is what? This is a piecewise defined function, so we consider the left and the right hand limit. Limit of f of x as x approaches to 2 from the right. So from the right, we consider this this expression. This is the limit of x squared as x approaches to 2 from the right. So this is 4. Then the limit of f of x as x approaches to 2 from the left. This is equal to what? From the left, this one. Limit of x plus 3 as x approaches to 2 from the left. This is 2 plus 3 is equal to 5. Now, take note, limit of f of x, the left-hand limit, or the right-hand limit, which is not equal to the left-hand limit. Why? Because the right-hand limit is equal to what? Is equal to 4, not equal to 5. Okay? Not equal to 5. In other words, therefore, limit of f of x as x approaches to 2 does not exist. Because we have a theorem that for a limit to exist, the left hand and the right hand limit must be equal. The limit must be equal. Okay? Since the limit does not exist in this case, therefore, what? This is f of x is discontinuous because the second condition is already not satisfied. F of x is discontinuous at x is equal to 2. Now, the discontinuity, we have determined that f of x is discontinuous at x is equal to 2. Now, this time, we are also to determine the type of discontinuity. So, what type of discontinuity is this? The limit, the left hand and the right hand limit are not equal. Okay? You go back to the description of the 4 types of discontinuity. This type of discontinuity is a jump discontinuity. Jump discontinuity. And you can verify this one. If we're going to sketch the graph of f of x, okay, how to sketch the graph? Since this is linear, so we have x plus 3, 2, 3. Using the mx plus b form, you have what? The y-intercept is 3, so 3. Then the slope is 1, rise over run. 1, 1, 1, 1. Okay? 1, 1, 1, 1. But x, this is 1, this is 2. 1, this is 2, this is 1, 2, 3, 4. And this is 5. This is negative 1, negative 2, negative 1, negative 2. So if we're going to sketch the graph of x plus 3, less than 2. So again, the y-intercept is 3, 1, 2, 3. Then you rise 1 unit, you run 1 unit to the right because the slope is positive. So 1, 1, 1, 1. Tapos you fall. Still 1 unit, fall, and you run to the left. So 1, 2. Supposed to be the graph looks like this. Okay? But since we're given the restriction that x must be less than or equal to 2, so instead of having this, the part of this graph, we're going to erase this one or delete this one. We are only considering the values less than or equal to 2. Dito. Okay, so this is the graph of x plus 3 if x is less than or equal to 2. Now, this one, x squared. X squared, what's the graph of x squared? It's a parabola opening upward because we have what? The leading coefficient is positive. The leading coefficient, what's the leading coefficient? It is 1. So the leading coefficient, so it is x squared if x is greater than 2. So if x is equal to 2, if x is, it's x squared, right? So if x is greater than 2, supposed to be x squared looks like this. Ganyan. Diba? But since we're given the restriction that x must be greater than 2, so if x is 0, 0 is not included here, the value is dito. If x is equal to 1, the value is 1. If x is if x is 2, the value is 4. Okay? Now, supposed to be, if without the restriction, x greater than 2, the value of x squared, if we are considering the values of x in the set of real numbers, so the graph, it looks like this. But since we are given the restriction that x squared siya, if x greater than 2, so the graph is only like this. It's only like this. But still, it's a parabola. Okay? It's a parabola. It's a parabola. If 3, it's 9. 3, 4, 5, 6, 7, 8, 9. So, somewhere here. But it is strictly, by the way, sorry, it should be hollow. Why hollow? Because x greater than 2. Okay, as you can see, it's a jump discontinuity. So our answer here is correct, and it is validated through the graph of the function. It is what? Discontinuous, and the type of discontinuity is a jump discontinuity. Okay? Then the next example. Okay, the next example, f of x is equal to x squared minus 7x minus 15 over x squared minus x minus 20. Okay? As you can see, the example here is a rational function. Why rational? It has a numerator and it has a denominator. The function expression here in the numerator is a binomial expression, and the denominator is also a binomial expression. Okay, so all we have to do is what? We're going to determine if the function is continuous or discontinuous at what point. Find and identify. So the problem, find and identify the points of discontinuity. Okay, obviously the points of discontinuity, those are points that can make the function undefined, and it is easy to determine because this is already a rational expression. So those values that can make the function undefined, or those functions or those values of x that can make the denominator 0. Okay? So to determine the values of x that can make the denominator 0, that can make the function undefined, we have to use factoring. So all we have to do is to factor this out, f of x. So we have solution. F of x is equal to x minus 5, 2x plus 4, 2x plus 3 over x minus 5, and this is x plus 4. Okay? Just check this one. If this, the denominator is equal to x squared minus x minus 20. And the numerator x minus 5 times 2x plus 3, or quantity x minus 5 times 2x plus 3 is really equal to this. Now you notice that this is a rational expression with common factors in the numerator as well as in the denominator. So it's already a clue that this we have a discontinuity. So what type of discontinuity? If it has a common factor in the numerator and denominator, it is removable discontinuity because the common factor can be cancelled out. So we have f of x is equal to 2x plus 3 over x plus 4. But, so, we were already determined one type of discontinuity. But there's another type of discontinuity because if x is equal to negative 4, the function here must also be undefined. Yes, it's also undefined because at x is equal to 4, at x is equal to negative 4, I mean, f of x is what? F of x is undefined. Okay, bracket. Why? Because if x is equal to negative 4, the denominator will become 0. F of x is undefined. Okay, in other words, if f of x is undefined at x is equal to negative 4, then x is equal to negative 4 is actually the vertical asymptote. Okay? So if the function has a vertical asymptote, then we can say that it has a what? An essential discontinuity at x is equal to 4. So in this example, there are two points of discontinuity. X is equal to 5. There are two values of what? 2 points. There are 2 points of discontinuity. Two points of discontinuity, that is at x is equal to 5 type of discontinuity. It is removable discontinuity. At x is equal to negative 4, the type of discontinuity is an essential discontinuity. Discontinuity. Okay? So these are types of discontinuity. Again, let us recall there are four types of discontinuity. First, we have the jump discontinuity, wherein the left hand and the right hand limit are not equal. Next is the point discontinuity. When can we say that it has a point discontinuity? If f of a, the function value is not equal to the limit of f of x as x approaches a. The third one is the essential discontinuity. We can say that there is an essential discontinuity if the function is a vertical asymptote. Okay? Then the fourth one is removable discontinuity, and it happens when the function is rational. It is a common factor in the numerator and denominator because the common factors can be cancelled out. Therefore, it has a removable discontinuity. And these are just a few examples of types of discontinuities. Now, in the next discussion, we might have a series of examples on continuity as well as on the last discussion about finding the what? Finding the trigonometric limits. Okay? So hopefully that you really understand what I'm talking here about types of discontinuity, and don't forget to subscribe.